Let's start today with L'Hopital rule. What's L'Hopital rule? L'Hopital rule to find the limit in a special cases. If you would like to have a limit when x tends to a for a rational function, you have a numerator and denominator. Okay, if you substitute in this one and you have 0 over 0 or infinity over infinity, L'Hopital says this will equal to limit when x tends to a. Okay. X tends to a for the same function, but you differentiate the numerator and differentiate the denominator separately. This is not division rule. It is not a division rule. Not a division rule. Because the common mistake is just thinking about it as division rule. So it is not division rule. Okay. Fine. Okay, what about if I have the same case? If I have 0 over 0 or infinity over infinity, keep going until you have a limit which has undefined value. Okay, and you keep going until when you substitute you have defined value. Once you have defined value, you stop. Again, here this is not division rule. This is differentiating the numerator separately from the denominator. Let's have an example for this one. Okay. Find limit when x tends to 0 for sine x over x. Of course, if I'm substituting limit x tends to 0 for sine x over x, if I substitute I will have 0 over 0 because sine 0 is 0, right? Okay, now using L'Hopital, when I'm using L'Hopital, and I will have this one equal to, yes, limit when x tends to 0, when I differentiate the sign, what is the derivative of sine? Cosine. Cosine, excellent. Cosine x over what is the derivative of x? 1, right? So when I substitute, I will have cosine 0 over 1. Cosine 0 is what? Is 1. So ليش كتبت sine? Sorry? The derivative of sine is cosine. I'm using L'Hopital rule. This is the L'Hopital rule, right? If I substitute and I have 0 over 0, as I have it here, I differentiate the numerator and differentiate the denominator, right? The derivative of the numerator, sine x, is cosine x. The derivative of the denominator, x, is 1. Now I am substituting, cosine 0 is 1, and 1 is 1, 1 over 1 is 1, right? Let's have another one. Okay. Find limit when x tends to 0, 1 minus cosine x over x. To solve this one, I'm just substituting if I have 1 minus cosine 0 over 0. Cosine 0 is 1, so 1 minus 1 is 0 over 0. Now I can use L'Hopital. Using L'Hopital rule. Okay, so to use L'Hopital, this will equal to what? Yes, limit when x tends to 0. When you differentiate 1, you have 0. When you differentiate cosine, you have minus sign, so it will be plus sine x. What is the derivative of x? Is 1. Now I substitute by 0, so I have sine 0 over 1. So I end up with sine 0 is 0, 0 over 1 is 0. Okay, easy. Okay, let's have another example. Okay. So you substitute first. Once you have 0 over 0 or infinity over infinity, you differentiate the numerator separately and then differentiate the denominator and substitute. If you still have 0 over 0, infinity over infinity, go for L'Hopital again. Okay. Limit when x tends to infinity, 2x squared over e to the 3x. Okay. Now, if you substitute, okay, if you substitute this limit when x to infinity for 2x squared over e to the 3x, if I'm substituting by infinity, I will have infinity over infinity. So now I can use L'Hopital. Now use L'Hopital rule. So what we have, yes, this will be equal to limit when x tends to infinity for, yes, differentiate 2x squared. How to differentiate 2x squared? 2 is a constant. X squared derivative is 2x squared. 2x, sorry. Okay. So the derivative of x squared is 2x. Now, what is the derivative of e to the power 3x? It is the same as e to the 3x, and then multiply by the derivative of the power, which is 3. Now I can substitute. If you substitute by infinity, you will have infinity over infinity. Again, L'Hopital rule again, right? So you will have limit when x tends to infinity equal to, differentiate again. What is the derivative of 4x? This is 4x, right?
Yes, 4.
It's 4. Excellent. So the derivative of 4x is 4. The derivative of 3e to the 3x is 3 e to the 3x times 3. So we'll end up, when you substitute, I have 4 over infinity. Anything over infinity will equal to what? 0, right? Any real value over infinity give you 0, right? This is how to, yes, I use L'Hopital once. I still have undefined value infinity over infinity. So I can differentiate the numerator again and the denominator, right? And I will get, by the end, I will have defined value. Okay. This is the only two cases, infinity over infinity or 0 over 0. No, there are some undefined values like 0 times infinity, 0 times minus infinity, infinity minus infinity, infinity to the power 0, 1 to the power infinity, and 0 to the power infinity. Let's have an example for this one. Okay. find limit when x tends to 0, infinity, and you have the function sine x sine 1 over x. Yes, without thinking, if I have my marginal here, so I will have infinity times 1 over infinity, 0 sine 0 is 0. So I have infinity times 0 or 0 times infinity. This is the case, okay? How to get this one to use L'Hopital? L'Hopital, as we said, we should have a rational function. So we have to have a numerator and denominator, right? So I should have fraction in my function. Okay. How to change this one into fraction? Sorry. Okay. Sorry. Okay. So this is the case. We have infinity times 0, so we can use L'Hopital rule. But L'Hopital rule, I just remind you, limit when x tends to a, and they should have fraction. Okay, I should have a numerator and denominator. This is equal to limit when x tends to a, and differentiate this one and differentiate this one separately, right? Substitute until you have defined value. Now, how I can make this one as fraction? Yes, I know. If I have 3, I can make this 3 as what? 1 over 1 over 3. Yes. Okay. So yes, this one, I can make it what? Equal to limit when x tends to infinity. Yes. Sine 1 over x, and I will have this one as 1 over x. That's great. Okay. If I substitute, I will have 0 over 0. This is the original case of L'Hopital. Yes, I can differentiate. I can use L'Hopital. So using L'Hopital, I will have limit when x tends to infinity. What is the derivative of sine? Cosine 1 over x. And what is the derivative of the angle? Minus 1 over x squared. What is the derivative of 1 over x? 1 minus 1 over x squared. How I can differentiate 1 over d by dx for 1 over x, I can make it like what? D by dx to the x to the minus 1. Yes, this is a rule. I get the minus 1 down and subtract 1. So I will have minus 1 x to the minus 2. I can get this one up to the power rule down. So I will have minus 1 over x squared. Okay, I'm lucky because I can cancel out this one with this one, right? So if I am substituting, so I will have, sorry, cosine 1 over infinity. 1 over infinity is 0. Anything, any value over infinity equal to 0, right? So this is 0. Cosine 0 is equal to what? 1, right? Easy. So again, if you have this case, you should have it as fraction or rational function, because L'Hopital is applied only on fraction like this. Okay. Now, let's have another example for this one. If you have find limit when x tends to what? To 0 from the right side for x cube ln x. Okay, if you substitute, just have our margin here. If I substitute,
Zero.
I'll have 0 times infinity, right? Okay, so I can use L'Hopital, but I have to use L'Hopital when I make this one L'Hopital rule. L'Hopital rule is applied for rational function. And if I have 0 over 0, I can have this one as a limit of the derivative of the numerator over the derivative of the denominator. How I can make this one as a rational? I know x to the power 3 is is 1 over x to the minus 3. So it is easy to get this one down with a negative power instead of the positive power. Okay, so I will have limit when x tends to 0 from the right side. I can leave ln x here and I get this down and I change the sign of the power up to the power rule. X to the m is equal to 1 over x to the minus m. Okay. Now, yes, if I substitute now, I will have, okay, undefined value, right? So I make it fraction. Now I differentiate limit when x tends to 0 from the right side. What is the derivative of the ln? 1 over x, right? What is the derivative of x minus 3? You get the power down and subtracting 1 from the powers, you have this one. Now, I can get this one up with a positive, right? So I will have limit when x tends to so I have 1 over x, okay, and this is here minus 3, and this one will be taken up by x to the power 4. So it is limit when x to the power to 0 from the right side. I have x, I can cancel out this one with this one. I have x to the power 3 over minus 3. When I substitute by 0, I have 0 over minus 3, so I end up with 0. The main point, to get these cases into a rational function. So you have to know the power rule, okay? And this is the case, okay? Now let's have another one. Fine. Limit when x tends to pi over 2 for tan x sine x minus pi over 2. Okay. Yes, I'm in my margin here. I will have, what is the tan pi over 2? Tan pi over 2 is equal to what? Tan is sine over cosine. I know sine pi over 2 is equal to what? 1. Cosine pi over 2 is 0. So I know this is infinity. What about the sine? Sine pi over 2 minus pi over 2 is equal to sine 0. Sine 0 is 0. So this is the case of, yes, infinity times 0. This is the case of infinity times 0. Okay, the main point, how to get this one as a fraction. I give you the clue now. I'm just telling you tan is equal to what? Sine over cosine. So this is a clue to get fraction here, right? Okay, so this is limit when x tends to pi over 2 using L'Hopital rule. Using L'Hopital rule. Okay. Now I write tan as sine x over cosine x, and I have here sine x minus pi over 2. Now I have the right one, or the right formula for using L'Hopital. Okay, so I have to differentiate the numerator and differentiate the denominator, right? Okay, because if you substitute now, you will have 0 over 0, right? So if you substitute now, you have 0 over 0. This is the original case of L'Hopital. Okay, now can you differentiate the numerator? Yes, it is a multiplication rule, right? It's a multiplication rule. The first one times the derivative of the second one. The derivative of sine is cosine. The derivative of the angle is 1, so no need. Plus the second one times the derivative of the first one. What is the derivative of sine? It is cosine x. What is the derivative of cosine in the denominator here? Minus sine x, okay? Now, if you substitute, what do you have? Substitute by pi over 2. So you have sine pi over 2 cosine. Please mute your voice, please. Cosine. When you put pi over 2, so you have 0 plus sine 0 cosine pi over 2 over minus sine pi over 2. Sine pi over 2 is what? Is 1, right? Cosine 0 is 1. Okay. Sine 0 is 0, so all of this one is 0. Sine pi over 2 is what? 0 or 1? 1, okay. So I end up with 1 over minus 1. I end up with 1 over minus 1, so it will be minus 1. Okay. Let's have another type of L'Hopital rule using in this limit find. Okay.
عادي ترد الصفحة شوي.
Sorry.
شوية بكتب.
Okay, take your time. Now to find the limit when x tends to infinity for x plus 2 over x minus 1 to the power x. Again, if I substitute by infinity, I have what? 1 to the power infinity. Okay, so this is the case of 1 to the power infinity. Why? Because this is having the same degree as we have in the asymptotes, horizontal asymptotes. So the limit will be 1, but you still have x here. So it will be 1 to the power infinity. This is the case here. Now, how I can make this one into fraction? How I can take the power into fraction? If you have x to the power m, and you would like to get rid of this one, how you can get rid of this one? Using the ln, right? So if you take ln For this one, you will take the m outside ln x. And now you can make it ln x over 1 over m. This is how to manage to get rid of this one. Okay, so just to not to get confused, what I'm going to do in this case is when I have a power, I'll just let y equal to x plus 2 over x minus 1 to the power x. Now, if I take ln for the left-hand side and take the ln for the right-hand side, now, yes, I know from the logarithm rule, x to the power m is equal to m ln x. Okay, so now what do you have? You have x ln x plus 2 over x minus 2, right? This is the ln of y. Now I will take the limit for both sides. You have to distinguish between the ln and the limit. This is the limit. I'll make it in red. X tends to infinity for ln y will equal to limit when x tends to infinity for x ln x plus 2 over x minus 2. Again, I should make this one as a fraction, so I can get this one down by making it 1 over x, right? Okay. Now, if I substitute now, I will have 0 over 0, right? So when I substitute now, I will have 0 over 0. Okay, so now if I substitute, I will have 0 over 0. Okay, so using L'Hopital, yes, now I can use L'Hopital. I will leave this one for you to have the derivative of the numerator. And I know the derivative of 1 over x is minus 1 over x squared. And I let you have the derivative of the ln is 1 over x plus 2 over x minus 2 times the derivative of this one using the division rule. So you have x minus 2 squared and you have x minus 2 times 1 minus x plus 2 times 1. Okay, and then you just substitute and I'll leave it for you. So how to get rid of the power? You let y equal to ln, okay, y equal to your function, and then you take ln for both sides. Now, I will give you this one, and I would like you to try it. Find limit when x tends to 0 from the right for x to the power x to the power 10. As I told you many times, you have to check when you put 0, so you will have 0 to the power 0. Yes, this is one of the case in L'Hopital. Again, how to get rid of this power? Yes, you know the power rule of the ln. X to the power m is m ln x. Again, to solve this one, this is the case. This is undefined value. Okay, so how to solve this one? You let y as x to the power x to the power 10. Now I will take ln for the left hand side and take the logarithm also for the right hand side. And I'm applying this rule for the logarithm. So I will have x to the power 10 down, and I'll have ln for only x. Okay. Now I can take the limit for both sides. Limit when x tends to 0 from the right hand side for ln of y is the same as the limit when x to the 0 from the right for what? Yes, x to the power 10 ln x. How I can make it fraction to use L'Hopital rule, right? So to use the L'Hopital rule, I have to make this one as a fraction, right? Yes, I know any power, I can get it down with a negative power, right? So this one will be limit when x tends to 0, okay? And I will leave the ln x up here, and I know x to the power 10 is 1 over x to the minus 10. So this one will be x to the minus 10. Now I am ready for the original case of L'Hopital because this will be infinity over infinity, right? So using L'Hopital, let's use L'Hopital. L'Hopital rule. To use L'Hopital rule, will be what? Limit when x tends to 0 from the right for what? For ln y, or for this one. So when you differentiate this one, ln x, the derivative of ln x is 1 over x. The derivative of x to the minus 10, I get the power down and subtract 1, so it will be minus 11. Okay. If I take this one up, it will be x to the power 11, right? So yes, it will be x to the power 11. So x to the power 11, and I have x here, so I cancel this one with this one. I have x to the power 10 over minus 1. When I put 0, 0 to the any power will be 0. Okay, but this is not the limit. This is the limit for what? For ln y. What is y? Y is this one. So how to get the original limit? So the limit for x tends to 0 from the right side for y only, which is equal to the limit when x tends to 0 from the right for x to the power 10 will equal to what? Yes, e to the 0. Why? Because I got the ln. To get rid of the ln, I will have e. So when I have e, I have to get e for each side, right? So e to the 0 is equal to what? Is equal to 1, right? Now I end up with my turn. I'll give you some example to get your turn. I'll stop recording. I'll give you the example, the exercise, and you'll try it. Okay.